Hello guys, welcome to Aramta Solutions. Welcome to another lesson on grade 10 graphs. Today we are looking at exponential graphs. So without any waste of time, let me give you a bit of introduction on exponential graphs. They come in the form y equals a times b to the x plus q. So, a bit of explanation. By now, you know that this is the output, right? You know this is the output of your graph, right? You know this is your output, your vertical scale. In other words, this is the value that goes to your vertical scale. You call it a dependent variable. Now, we're going to come back to this value here and this value here. This, you've known it to be your input variable, your horizontal, it's on the horizontal scale, okay? It's on your horizontal axis. So it's on your horizontal axis. Maybe let me not say scale, but rather say axis. And then this guy, as is the case for every graph or every function, it's vertical shift. Remember, if you don't want to say vertical shift, you can say it's vertical translation. Okay, if you don't want to say shift, you say translation. So if you remember well, if Q is positive, your graph will shift up. If Q is negative, your graph will shift down. Okay, as was the case with hyperbola, it also represents horizontal asymptote. Okay, it also represents horizontal asymptote. So your horizontal asymptote is y equals q. Okay, your horizontal asymptote is y equals q. So what is happening now is we will be investigating this graph. Before I can give you further information on A and B, we will be investigating these graphs. So for starters, let's start. 1, we will be looking at y equals b to the x. All right, this is what we will be looking at. So what we are looking at here, I want you to notice, remember we said y equals a times b to the x plus q. However, when we say y equals b to the x, this means our a is 1, our q is 0. All right, cool. So for the investigation that we're going to do, we are going to look at these graphs. So we're going to say sketch the graphs of f of x equals 2 to x, maybe let me say, and g of x equals half to the x. Okay, now something that I also need to mention, for your graph to be an exponential, b must not be equal to 1, or it must also not be, it must also not be equal to 0, or it must also not be equal to 0. So it must be greater than 0, but less than 1, and then it must be greater than 1. Okay, so basically b is not equal to 0, so yeah, b is not equal to 0. That's all I can say right now. So now let's try to find these values. We're going to use our table. So we're going to use our table for on our calculator. Okay, so I'm going to give you, let me see, -3, -2, -1, 0, 1, 2, 3. So it's gonna be f of x, it's gonna be g of x. So let me not so okay, all right. So now let's see, we have f of x is 2 to the x. Let's imagine 2 to the minus 3. 2 to the minus 3 would be 1 over 8. 1 over 8 should look like 0, 0.125. And then 2 to the minus 2 would be 0, let me see, would be 0, 0.25 because it's 1 over 4, so it's 0, 0.25. 2 to the minus 1 would be half, 1 over 2, so half is 0, 0.5. 2 to the 0 would be 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. This guy, let me write him in blue. It's similar to saying 2 to the minus x, right? It's similar to saying 2 to the minus x. So this guy will be, let's see, this guy will be 2 to the minus 2 to the power minus 3 would be 8, and 2 to the minus 4 minus 2 would be 2 to the 4, 2 to the 2, which is 4. Okay, I think it's the reverse of this. 1, 0, 0.5, 0, 0.25, and 0, 0.125. Okay, so now I want us to plot these graphs. So let me copy them. Okay, so I'm gonna copy this value here, and we're going to use it in the next page. Okay, so this is your table, so I'm going to use it in the next page. So let's see. Okay, now we can try to plot. Let me see. Let me try 9. Okay, I'm gonna use black. Okay, I'm gonna try 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 must wait a bit. And then this is 0, 1, 2. So this is 1, 2, 3, negative, negative, 1, 2, 3. X axis and y axis. Right, so now I'm gonna start plotting f of x. F of x, when y is minus 3, it is about 0, 0.125. So let me say 0, 0.125 could be somewhere here. When x is minus 2, it is quarter. Let me say quarter is here. Half, you are here. 1, 2, 4, 8. All right, so this is Let me join them. I'm sorry. Okay, I think I'm getting it. Okay, okay. So this is f of x equals 2 to the x. All right. Now let's try g of x. I'm going to change the color. Let me use the green. 8, 4, 2, 1, half, quarter, half of quarter. Right. Now this one here is g of x equals half to, no, let me not squeeze it, not right. G of x equals half to the power x, by the way. So something that I want you to see, let me go to the previous page. So here with f of x, f of x equals 2 to the x. A is 1, b is 2. Obviously for this example q is 0. With g of x, b, a is 1 again, b is half, again q is 0, right? So you have seen how the graph looks like. Remember, we are investigating, okay? We are investigating. So in this investigation, basically it is when a is equal to 1 and q is 0. Now let's go to a second case. In the second case, we going to look at one, again, y equals b to the x. Okay, so here we will sketch f of x equals negative 2 to the x and g of x is negative half to the x. All right, so now we have again x, g of x, oh sorry, f of x, and then g of x, right? So let us try minus 3 minus 2 minus 1 0 1 2 3. Okay, so oh boy, I don't know why it's deciding to not be straight. Okay, all right, now let's see. I remember we said 2 to the minus 3 was 0, 125. Let me confirm, not 2 to, yeah, 2 to the minus 3 was 0, 125, but now it'll be negative 0, 125. It will be negative 0, 125. This one was 2 to the minus 2 was a quarter, so it'll be negative quarter. This one was a half, so it'll be negative half. This one was 1, so it'll be negative 1, negative 2, negative 4, negative 8. All right, negative 8. Now we then look at half of 2 to the what? 2 to the minus 3. I think we said it was 8, but because of the negative, it'll be negative 8. I think it'll be negative 4. It'll be negative 2, it'll be -1. It'll be oh, sorry, I see a mistake that I did here. There's a mistake I did here. This one is 0, 0.25. It's 0, 0.25, so negative. So this one is negative 0, 0.5, negative 0, 0.25, and then negative 0, 0.125. All right. Before I continue, I want to address something. In this graph here, guys, I want you to notice something. And the thing that I want you to notice is this. I want us to try to find an x-intercept. Okay, I want us to try to find an x-intercept here. So, x-intercept, okay? So I want us to try to find x-intercept. So x-intercept, where there's y, we put 0. Tell me that you're not getting an x-intercept. You cannot, right? Now, since you cannot, this should tell you that y should not be equal to 0, right? Y should not be equal to 0, right? Y should not be equal to 0. Now, something that I think I didn't do and I want to correct it is that since we said y is not equal to 0, this should tell you, let's look at our domain, right? Let's look at our domain. We don't have an x-intercept here, okay guys? We don't have an x-intercept here. So this should tell you when f of x is 2 to the x, what is our domain? And I will tell you, domain is always x is an element of real numbers, right? Always. Okay, domain is always x is an element of real numbers, always. But now let's talk of our range. Our range, remember we're talking of set of output values. I said to you y should not be equal to 0. So this should tell you that this thing accepts, the exponential accepts all y values, but there is a condition. In this case, when you look at it, it can accept all y values, but they must be greater than 0. Right? They must be greater than 0. So I can tell you right now, what is 0? Y must be greater than 0. What is 0? 0 is Q. Okay? We will expand on this later. Okay, next one. Now, on this one, we need to look at a few things here. Let's look at f of x. It is minus 2 to the x. So this means a is -1, and then b is 2, q is 0. Cool. G of x is -½ to the x. Remember, I said this guy, you can also write him as 2 to the minus x, okay? So, a here is -1, b is half. What is q? Q is 0. Remember, the domain, as usual, the domain is always x is an element of real numbers. Right? But for you to see the range, we need to start drawing the graph first. Okay, so for you to see the range, we will have to start drawing the range, to draw the graph first, okay? So now let's go. Now, I'm going to try 9, 8, 7, 6, 5, Oh boy, no, not that. Let me start with 1, 2, no, 1, and then here let me just have my x-axis, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, negative, 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 negative. Negative, 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 and you're here, buddy. 0, 1, 2, 3, 1, 2, 3, negative, negative, negative. All right, so we said let's start plotting. I'm gonna move, okay, let me move it a bit because I will want to say something. So let me give myself a space. Nah, it's a waste. I don't have to. It's fine. Let me just continue. So let's plot f of x. When x is minus 3, it is... I have to change the colors. Okay, let me give it a red. It is half of a quarter. I hope it's this one here. When x is minus 2, it is a quarter. I hope, but it doesn't matter. When x is 1, it is negative half. When x is 0, it is 1. When x is 1, it is minus 2. When x is 2, it is minus 4. When x is 3, it is minus 8. Okay. I'm sorry I skipped that, but yeah, it is. Let me just move it here. It is here. Okay. So this one is f of x equals negative 2 to the x. Okay. All right. Now I'm gonna try the other one when it's minus 8, minus 4, minus 2, 0, half, quarter, half of a quarter. So it'll be, it'll be someone is misbehaving. Okay, something like that. Now this one is g of x equals negative of half to the x. Now I want you to see something. Our domain is still x is an element of a real number, right? But our range is y is an element of real numbers, but we have shown that it'll never touch x equals 0 when it is in this form. When q is 0, the graph will never touch the graph will never touch y equals 0. So we will never have an x-intercept here. All right. So we see that it looks like it is all y values that are below 0. Can you guys see that? The range can accept all values of y, but those values must be below 0 or must be negative y values. Okay. Now remember, this is when a is negative. Now remind yourself when a was positive. When a was positive, it was, the range was saying y values must be greater than 0. Can you guys see that? Now here I had said this is y is not equal to 0. So this should tell you that you have what, let's call it the asymptote, because the graph will never touch this graph. It's the asymptote. So horizontal asymptote. Okay, so horizontal asymptote is y equals 0. Y equals 0. What is this y equals to 0? At y equals to 0, this is where we said we had y equals q. Sorry, so this value represents y equals q. So the horizontal asymptote is y equals q. Now, let's go back. Now, still here, horizontal asymptote. So still here, horizontal asymptote, we're still going to say y is equal to 0. So, because I used red, horizontal asymptote is here. Okay, but it doesn't show here. Okay, it's here. As you can see, the graph will never touch this. Okay, so this is your horizontal asymptote. Okay, this is your horizontal asymptote. Now remember, horizontal asymptote is always y equals q, as was the case with hyperbolas. Now let's go to case 3. Now let's go to case 3, which will be interesting. Now with case 3, we are now shifting them. But it says to me we don't necessarily need to be doing it, but we will do it. I'm just gonna take one which will make things easier. Let's see, number 3, we are then looking at y equals b to the, okay, y equals a times b to the x plus q. So we're going to sketch f of x equals 2 to the x plus 1 and g of x equals 2 to the x minus 1. Okay, now let's quickly draw a table. Let me make it horizontal. So I'm gonna say x, let me start at minus 2, minus 1, 0, 1, 2, 3. Okay, yeah, that's fine. Okay, is it fine? Yeah, that's fine. So let's look at f of x. When 2 to the minus 2 is a quarter plus 1 would be 1,25. 2 to the minus 1, okay, (1,25). 2 to the minus 1 is a half, so this is 1,5. Remember, half plus 1. 2 to the 0 is 1. 1 plus 1 is 2. 2 to the 1 is 2 plus 1, 3. 2 to the 2 is 4 plus 1, 5. 8 plus 1, 9. Now, g of x. Now, oh boy. We have, let me see, 2 to the minus 2 is a quarter. A quarter minus 1 would be negative 0,75. Negative 0,75. And then half minus 1 would be negative half. Now 2 to the 0 is 1. 1 minus 1 is 0. 2 to the 1 is 2. 2 minus 1 is 1. 2 to the 2 is 2. 4 minus 1 is 3. I guess this one should be, because I see difference of 2. I guess this one should be is it? Yeah, I guess this one should be 7. Okay, I guess this one should be 7. Now let's try to sketch it. Maximum is 9. Maximum is 9. So let me see. 9, 8, 7, 6, 5, 4, 3, 2, 1. 1, 2, 3. I guess it's enough. Y, X. 1, 2, 3. 1, 2. So let's try to to plot. Okay, something as well that we need to understand here. A is 1, B is 2, Q is 1. And here A is 1, B is 2, Q is -1. So this means this guy has shifted 1 unit down, this guy has shifted 1 unit up. So I'm going to start with f of x. F of x has shifted 1 unit up. So this means we must draw this line here. Right? Now we start plotting 1,25 must be a quarter. A quarter is somewhere here. And then 1,5 is a half. And then 2. And then 3. And then 5. And then 9. So okay, so this is f of x equals 2 to the x plus 1. Now let's look at g of x is 2 to the x minus 1. I'm gonna change the color, so let me give it a green one. So it's -1, so this means normally, remember, normally your asymptote is here, but now it has shifted 1 unit down, so it'll be passing at x equals -1. So let's see, -2 would be -0,75. -0,75 would be here. -half obviously is here, and then a 0 and 0. Okay, and then what else? 1 and 1. Okay, 1 and 1 is here. 2 and 3. 2 and 3 is here. 2 and 3 is here. And then a 3 and 7. 3 and 7 is here. Okay. Okay. Do you guys see that? Now this graph has shifted 1 unit down. Okay, it has shifted 1 unit down. So this shift doesn't matter whether your A is positive or negative, it'll always be like this. Hence I didn't want to draw lots of them. So I want to give you guys something before we end our lesson. But do not worry, we're going to summarize our lesson before we conclude. So I want to give you something, effect of the value of B. Okay, I want to talk about the effect of the value of B. So yeah, I want to talk about the effect of the value of B. Of the value of B. Okay, so I want us to try this guy to sketch f of x equals 2 to the x. F of x equals half to the x. Oh no, sorry, g of x, not f of x. And then h of x is 3 to the x. Okay, so I'm gonna try x 0, 1, 2, 3. Okay, and then I'm gonna try f of x. F of x, I would have 2 to the 0 is 1. Obviously, even that one is 1. Oh, sorry, I'm saying even that one. 2 to the 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. Now let's try g of x. G of x, 2 to the 0 is 1, and then 2 to the 2 is a quarter. Oh, 2 to the 1, no, sorry, 2 to the 1 is 0, 0.5. Now 2 to the 2 to the 2 is a quarter, and then 2 to the 3 is 0, 0.125. Okay, now let's look at h of x. H of x is 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3 is 27. I will not be drawing until 27. So I'm just gonna try 9, 8, 7, 6, 5, 4, 3, 2, 1, and then 0, minus 1, minus 1. Not that I need to go there. 1, 2, 3. Okay, so first thing first, let me start with f of x. It starts here. 1 has 2, 2 has 4, 3 has 8. Okay, so this is please remember guys, this is not a straight line. Okay, so this is f of x. So this is f of x equals 2 to the x. Let me try g of x. I'm gonna use this color here. 0, 0.5. What is this? It's 0, 0.5. Does it help? 0, 0.5. Okay, maybe this guy doesn't help because he's gonna be like this. So it doesn't help. Let me ignore him because he doesn't help. Let me try 3. H of x. So h of x, 1, 1, 1 and 3, 2 and 9, 2 and 9. Okay, 2 and 9. But okay, this one is h of x equals 3 to the x. Now I'm going back to my g of x. I'm going back to my g of x. G of x is half, 0, 0.25 and 0, 0.125, something like that. Okay, something that I want you guys to see is this. As b gets larger, I want you guys to see it. As b gets larger, remember this one is the smallest b, which is half, 0, 0.5. As b gets larger, graph becomes steeper. Yeah, let me use the word steeper. Okay, as b gets larger, graph becomes steeper. Can you see from here? Check, this one was sorry, it was g of x equals half to the x. Can you guys see that? I know I'm tempted to say 0, 0.5, so it is 0, 0.5. Okay, so look at it. As b gets larger, graph becomes steeper. Can you guys see that? It becomes steeper, 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 steeper. So if you had 5 to the x, it would be, you know. So basically we're trying to say that as b gets larger, your graph gets closer to the y-axis. Can you guys see that? As b gets larger, your graph gets closer to the y-axis. Okay? Now, we have somehow covered all that we need, but we need to summarize what we have been studying today. So, in summary, A, when it's positive, we should somehow be saying the graph curves upwards, right? We should be saying it curves upwards. When A is negative, the graph curves downwards, right? Why am I saying that? Do you remember? It was like this, okay, and then like this. You will understand when we deal with concavity later in your high school. And then it was also like this. Let me go back to the slides. Okay, as you can see, do you see this one? Okay, so maybe let me try to start with this one here. So it was like this and like this. Can you guys see that? So now another thing that you must notice when A is positive is that it lies above asymptote. And then this one lies below asymptote. Right, this one lies below asymptote. So let me go show you. When A is positive, here is your asymptote. Your graph lies above the asymptote. Can you see that? Look at when it's negative. When it's negative, your graphs lie below the asymptote. Can you guys see that? Your graphs lie below the asymptote. Right? Now, there is something that I think this is all that I think we can say about the A's. Yeah, I think this is all that we can say about the A's. But the B's, we somehow need to be careful with regard to the B's. Okay? So, now, check this out. When Q is greater than 0 and B is greater than 1, your graph looks like this. In the same manner, when Q is greater than 0 and B is less than, it's greater. Let me start with greater. It's greater than 1. Your graph looks like this. Let me confirm. Okay, so this is, greater than, it's like that. I was right. But now, with the Q, we need to be careful. So I need to add something here. Right, this is what I need to add. So check this out. when a was negative, do you see what is happening with the graph? It is below the x-axis, so the q doesn't have much of an effect. Can you see that? The q doesn't have much of an effect. Now check this out again. When q is positive, the q doesn't necessarily have an effect. Okay, q doesn't necessarily much have an effect, because here we're basically saying greater than 0. It's like this. So let me redraw this to make sense. So here we will have greater than 0, so it'll be, so your graph will be, let's say, okay, something like this. Now let's look at when q is negative. When q is negative and b is greater than 0 but less than 1, what are we looking at? So here we're looking at it, it'll be like this. So it shouldn't matter. Q doesn't have much of an effect, so b is greater than 0 but less than 1. Remember, this is when a is negative, so how will it be? It'll be like this. Can you see that? It'll be like this. Let's confirm. Can you see can you see this? Can you see this? B is greater than 0 but less than half. It's like this. Okay. Okay. All right. So whether q is so with regard to q being negative, it doesn't necessarily matter. So it doesn't necessarily matter, because all that it means is that, let me use a different color, is that this guy will be basically coming here and your graph will be like this. So it doesn't have much of an influence. Okay, it doesn't have much of an influence, as long as you know that, one, when a is positive, your graph lies above the asymptote. When a is negative, your graph lies below the asymptote. As you can see, it's below the asymptote. Right? So guys, this is all that you need for exponential graphs. We are not doing much examples as yet, like finding the equation and all that, but we will have a time where we look at them. Okay, so for now, this is it. Bye bye.